Good morning, everyone. My name is Ina Aparicio. I am the Web Marketing Specialist here at Enterprise DB. I will be your host today for our webinar, Exploring 10 Postgres Tips and Tricks. I am joined today by Bruce Momjian, EDB Senior Database Architect, as well as co-founder and core team member of the PostgreSQL Global Development Group. Before we get started, I just want to go through a few housekeeping items. So first of all, this presentation is being recorded, so we will be sharing the recording along with the slides after the broadcast. Second, the lines are muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 1 hour, and we expect the presentation to last approximately 45 minutes, and we'll allot any extra time for question and answers. If we do not have time to address all questions, we will be following up afterwards with any attendee whose question was not answered. And now, without further ado, here's Bruce.
Hello, everybody. Hi. It's great to have everyone here today. I'm very excited about this webcast because it's different and new. And for me, different and new is always fun. My name is Bruce Momjian. I am one of the Postgres core team members. Been working with Postgres for 23 years and been with Enterprise DB for 13. I attend a lot of conferences, work on the source code, and help to encourage new developers to get involved with Postgres. You might wonder why this presentation is new and different. Well, normally, and for those of you who've been to my presentations before, normally my presentations have very detailed slides, very polished. Somebody said, you could really study the slides after the presentation to see all the little details that I've sort of put in there. And it takes a long time to do that. And of course, it's very good for structured information where you're starting with something very simple and you're working to something very complex. But that's not this presentation. This presentation is kind of a grab bag of some of the sort of nooks and crannies of Postgres that I think are really interesting, but are kind of small enough that you can mix them together with a bunch of other things. They're not big enough for a whole presentation, but that doesn't mean they aren't useful and important. So what I've done here at the prompting of EDB Marketing, who had this idea, was to create a presentation that just has sort of the 10 or 15 things that I think are really interesting about Postgres. Things you may not have heard of before, may be obscure, and I'm going to present those today. In addition, some of it's going to be live demo, which is another thing that I normally don't do because obviously that can be fraught with who knows what problems. But I think it's going to go well. I think it's exciting to have live content sort of mixed in. So without any further delay, I want to get started. I promised to give you some tips and tricks, and here we go. I've basically separated the tips and tricks into 6 sections. So we're just going to walk through. Each section has 2 or 3 items. One of the problems I've seen with sort of tips and tricks or demos, it makes it very hard for you to kind of go back later and really research what you saw. Like you see the webinar and you're like, oh, that part was really cool, but I'm not sure what that was exactly, or gee, I remember something. So what I effectively did was to add specific URLs to every item. So every item has a URL next to it. If you want more information after the webinar or even during the webinar, you can just go to that other URL. This slide deck will be emailed to you. And again, it's just a PDF. You can click on any of the text, any of the URLs, and it'll just open in your browser. So again, I tried to make it real simple. I hope this is considered to be useful to everybody. And if it is, I'll be glad to do it again. Again, the goal here was to do something kind of out of the box, something different that we haven't done in the past, and really kind of dive into some obscurities that you may not even know existed, and may be kind of interesting to you. I'm kind of somebody who likes obscure things. I like to understand how everything works, and some of the polish I think that Postgres has kind of comes out in this webinar. So let's get started. I'm going to start with number 1. There are 15 items. I know we promised 10, but hey, we under promise and over deliver at Enterprise DB. So we actually have 15 items. And again, we'll be able to cover this in the time allotted. The first one is something called Smart or Smart Tools. If you've never heard of Smart, I suggest you find out what it is. Smart is effectively a industry standard way of monitoring the health of storage hardware. I think it does a little more than that, but that's normally what it's used for. I mentioned that every entry will have a URL associated with, and this one does as well. And in fact, because it's a PDF, I can just put my mouse on there and click on it. Oh, sorry. Um, that's kind of interesting. Okay. Click on it. It didn't want to click there. I don't know why. And this is actually a blog entry I did in 2012 about smart tools. But again, we're not going to be so concerned about that because I want to show you a demo. So we're going to actually do a demo in a minute. Hold on. Let's wait for that to load up. Not displayed correctly. Interesting. Kind of odd. Let's just reload it. Sorry about that. Okay. And we'll go back here. And okay. So we're gonna go here. Now this is my server. It's a Debian system. Debian what is it? Is it not Jesse? It is Stretch. Debian Stretch. Debian 9. And if you look at my drives, you can see a number of drives here. This one happens to be an SSD, and this one is a magnetic disk. So what I'm going to do is I'm just going to type smart ctl-a, and I'm going to put in that drive letter. I'm not going to put in the number. I'm just going to put in the letter because the number is a partition on that drive. I really just want to talk about the whole drive. And if I type it too less, you can see every mistype I do. It actually tells you quite a bit about the drive. So this is the drive. It's an Intel SSD, Intel 320, somewhat old at this point, but it works quite well. Here's a whole bunch of information about how long it's been up and the firmware version and so forth. But this area down here is really the most important part. This is a list of all of the characteristics of the drive that are monitored by the smart system. And in fact, for an SSD, this is probably the most interesting line right here. Here is the wear level indicator. So that indicates that 93% of the drive's wear is still available. So this drive's been in service for probably 6 years, and it says that 7% of that drive has been worn out. 93% is still available. So that's, again, a really good metric. Now, I don't expect you to be running smart ctl-a all the time. What effectively you want to do is to set up something called Smart D. And as you can see, Smart D will wake up every so many minutes and will monitor the health of your drives. Okay? Think of Smart as effectively the warning lights on your car when it says, low tire pressure or low oil or your engine's overheating. You like to know those things, and by installing Smart, you effectively get that capability. And it will basically tell you how if there's anything that the drives are reporting that could indicate that a problem is coming. It's not perfect, just like the lights on your car aren't perfect, but I think it's very, very helpful to have. So that is what I wanted to talk about Smart. I think, again, for people who want to use a very reliable database, you have to have reliable hardware. And of course, that's what Smart helps you do. Obviously, if you're operating in the cloud, it's a little different, but cloud would give you its own metrics. So that's what I wanted. That's the first obscurity. The second thing I want to talk about, again, relating to drives, again, we're in the hardware section, is PG Test FSync, which you may find kind of unusual, but I'm going to kind of run it again. You remember I said that I have a SSD drive. So what PG Test fsync does is, well, I'm going to just go to my directory. Any directory, doesn't matter. I'm on the SSD right now, so I can take pg test fsync, and then in the current directory, it is effectively going to do a whole bunch of fsync tests on that particular drive. And I'm going to get performance numbers back. So if you're curious of how well that drive is fsyncing, I'm not going to go into what fsync does, unfortunately, but fsync is the ability for the drive to provide durable hardware. You can see I'm getting pretty good numbers, and it's also giving me numbers related to how quickly I can fsync one 8K block, two 8K blocks. That's the process it's doing now, and it's actually using different fsync methods. So there is a configuration parameter in Postgres which allows you to choose the fsync method, and you can actually use pgtest fsync to figure out which fsync method for your operating system, for your hardware, is the fastest. In fact, in my example, it looks like it's probably either Open Data Sync or F Data Sync are the two that are the fastest. And in fact, it's looking like Data Sync is the fastest because Open Data Sync would have to do two fsyncs for an 8K block, whereas F Data Sync is only needing one. So again, sort of some characteristics of how your system is running. For those of you looking for good performance, that's always a good metric. At the bottom, we have non-sync write. This is basically my raw performance for the drive. Now, you might think, okay, that's kind of interesting, but how does that relate to something else? Well, if you look at these numbers here, it's in the thousands. So you're looking at about 6.5 thousand ops per second. And again, a very, very healthy looking non-fsync write. Now, if I go over to magnetic media, and now this is a magnetic drive, this is not an SSD, and I run the same test, you see dramatically different numbers. So we've gone from 61, really 6100 to 61, which is really bad. Keep in mind that this is actually configured to honor fsync. It's not cheating. It's actually waiting for the data to get to the platters, and it's going to run this test. I'm not going to let the test finish, but you get the idea. Doing an fsync on an SSD in our experiments here is about 100 times faster than doing an fsync on magnetic media. What I did do to tell the system that how to handle fsync is I actually turned on the write cache for the different drives. So here the write cache is on. I actually ended up turning off the write cache for the archive drive, but again, I did an fsync, so it probably honored that. But again, you get the example. This is the HD parm file, and this is where you control whether you want the cache to be honored or not honored. I actually don't do fsyncs on the magnetic disk, so I just turned it off. But again, I did mention it on the slides, and it's mentioned in the blog, I believe. pgtest timing, another tool. We do a lot of timing in Postgres, obviously for a whole bunch of different reasons, particularly for explain plans and so forth. And what this is telling me that my timing loop for various options is pretty good. So here it's telling me I've got 96% are under 1 microsecond, which is about what I expect to see. Okay. So that's it for hardware. Over to internals. Frankly, I've always been interested in the way that the Postgres internally runs. That's just always been interesting to me. So we're going to open the backend flowchart. There actually is a backend flowchart in Postgres at this URL, which allows you to kind of see a flow chart of how queries are run in Postgres. We have the postmaster, we have the Postgres processes, we have the parser, the rewriter, the optimizer, and the executor. Anyway, I've always found this internals to be really interesting. What's kind of cool is you can click on a single section, and it will actually open a wiki page which explains what that particular box does. And then you can even click on the section, the name, to actually see the source files. So this is the source file for that particular C file that's in that module. So again, I think it's kind of interesting if you're kind of curious about how the source code works. That's kind of a neat way of kind of popping around. Another example I also think is quite useful is the flowchart diagram. This is something I wrote a while back. Let me full screen it for you. This is something I wrote a while back, which basically shows the flow of queries from libpq, which is where the query comes into the server, to the backend, to the scanner, which is the parser, to the rewriter, to the optimizer, and then to the executor. And it even has the name of the functions that represent these things, and then back to libpq, which then returns the results. So again, this is a static display. You can't click on it. But again, if you're curious how that flow works, have at it. I think it's a cool thing. Obviously, very high on the obscure scale for normal people who don't work in the back end all day. But I think it's quite useful. Okay. Moving ahead. No, actually we don't. Yeah. Okay. So. Okay. So moving ahead. PSEF and top. This you might not think this has a whole lot to do with Postgres, but Postgres is actually very good at giving you control over what Postgres is doing at the operating system level. So, for example, if I run a benchmark, which I'm going to do right now, so I happen to have a benchmark here. I'm going to run a PG benchmark. I can actually run htop or top, and I can actually see what Postgres is doing. I can do it with PS. You can actually see Postgres doing a copy operation right here. Here's the copy actually occurring, and here's the copy right here. Again, top shows me as well. I think I have to do. Oops, sorry, I'm getting confused on top here. Yeah, so if you run top, and then I think we have to type C. So you have to type C in top. Now it's telling me to do a vacuum. Now it's telling us it's doing an alter table. And it's still kind of chugging through. And then it's going to start. Yeah, then it goes all full. So as you can see right there, we've got commits running, idle transaction, updates going on. What I'm trying to point out here is the system is effectively showing me in PS and in top what is going on. Doesn't show me the full query, just shows me the type of command, update. It doesn't show me the full what I'm updating. It just says updating. And again, same thing for select or insert or whatever. So again, I think that's kind of cool that you can do that from the command line. Timing a query, I talked about that before. If you want to time a query, remember we talked about PG test timing, that we do a lot of timing in Postgres. So timing a query is kind of a complicated process because you have to figure out what you want to time, right? So in the first example, I want to time the full round trip time for my query. So the first word at the command line on my client is timing from the client's perspective. How long is it taking to start up the app, send the query, get the result back, and shut down? Okay. And in that case, it's actually showing me 0.3435 milliseconds. But at the same time, I ran logmin duration statement equals 0 for this session. So I can also see that from the server's perspective, it took 318 milliseconds. So what this is showing me is that not only am I timing the entire round trip, but I can figure out how much of that round trip was on the server side and how much of it was starting up the app, sending the query, getting the result back, and then processing it. Okay. So that's quite a bit of time. But it's not unreasonable because you're starting up a server and you're a new query and doing everything all. But again, when you're timing something, figure out what you're timing, because that can make a big difference. In fact, down here at the bottom, I can get this URLs in the thing. Down here at the bottom, we have a list of how long it takes to start up various sessions. So, for example, with SSL, it's actually quite a bit more expensive than non-using SSL, and it's even less expensive if you use Unix domain socket. Okay, kind of showing you that trade-off in the network setup time, which I think is kind of interesting. Okay. If you're interested in more detailed timing, we can do this. This is actually showing you how you can time something inside the server. So before we said, how long does it take to run in the server? How long does it take to do the network round trip and so forth? What this is doing is it's actually turning on timing for the stages that we saw in the flow chart. Remember, we saw a flow chart previously, and it had a parser, had an optimizer, had an executor. Well, what we're doing now is we can actually see how long it takes for each section. So if I kind of kill that, and let's see here, am I still running? My bench is done. My PG bench is done. But if I go into Postgres and I say set client min messages equal log. Oops, sorry. I always think it's message. Anyway, and then I say set log parsers, like log. What were my options here? Parser stats. So log parser stats equal true. Set log planner stat. Oops, equal true. Yeah, it gets a little more crazy, right? Set log executor stats equal true. When I do a select 100, for example, I now see on my screen, I'll scroll up a little bit, I now see the various statistics for each stage of the query. So here's the planner time, the rewriter time, the parser time is up here. So here's the parser time right here. Here's the parse analysis time. Here's the rewriter time. Here's the planner time. And then down at the bottom is the executor time. And I can see what the elapsed time was. I can see what the system time was, the user time, and I can even see how much page faults I had, how much I/O it did. Again, a lot of details. So I guess my point is that not only when you're timing something do you need to think about the round trip time for the query over the network and the client time, but also the time you can go into the server and then look at how much each stage took for that particular query, which may be interesting to you. Okay. Okay. So that's what I want to talk on that one. GUC levels. This is kind of an interesting one. I'm not sure how many people are aware of how many ways you can set server variables, but there's a whole bunch of them. You can set, and I've got it listed right here. You can set server variables in Postgres Conf. You can set variables at the user level or the database level. You can set it at the session level, which is what I just did with log parser stats. You can do it at the function level or at the transaction level or sub-transaction level. And each lower level overrides the level above it. So if you set something in Postgres Conf, but you change it in the session, that session value overrides what's in Postgres Conf. If you set it at the transaction level, that overrides what you set at the session level. I don't have time to demo this right now, but again, be aware of that layering. A lot of people understand Postgres Conf, but maybe they don't realize how many other layers are here for you to do stuff. It's I know it seems really simple, but it is incredibly powerful what it allows you to do. Okay. Workmem. This is a good one. A lot of people have questions about Workmem, and again, this blog entry from 2012 really explains it, I think, very well. And I'm going to hop down to the bottom to give you the summary there. But effectively, what workmem does is it allows you to use more memory for sorting and hashing. And by using more memory for sorting and hashing, you're not spilling to disk for large result sets, and that can have dramatic speed improvements. If you look at the numbers right here, and again, feel free to run these queries if you wish, but effectively, you can see if you're spilling a large query to disk, to magnetic disk, it can take 68 seconds. SSDs drops that to 36. Even using memory, an in-memory file system doesn't drop it that much. But again, using a high work memory really does have impact. But on the other hand, and this is unfortunately something I can't get into in the length of time we have, but there's something that I wrote in December of last year called the memory resource triad, which you can see the three items listed here on the website, 1, 2, and 3, shared buffers, workmem, and kernel buffers. And there's this sort of competing, I would say, competing priority for where to put your memory. If you give too much to shared buffers, workmem suffers. If you give too much to workmem, kernel buffers suffer. And what I'm trying to get at here is you've got one resource, which is memory, and you've got three potential places to put it. And it's really hard for Postgres to automatically figure out where to put the memory. Effectively, what we normally tell people, and again, I have some blog entries about this, is probably try and go to the low end. This a blog entry explains it. If you undersize 1 and 2, it turns out that the system will sort of compensate and use kernel buffers to kind of take over for the lower estimates if you have a spiky workload. On the other hand, they have this behavior, if you overestimate how much you need in these, you almost always will cause a problem. So again, it's this really weird thing. So here's the good news is that Postgres is less sensitive to non-optimal memory allocations. And again, it's really kind of a philosophical issue of how that sort of works. There's nothing unique to Postgres about this. It's a common problem. But what I was trying to get across is how those three competing resource options really interplay. Okay. Transactional DDL. I think that's really kind of an interesting capability. I know many people haven't maybe heard about this, but effectively in Postgres, you can create, you can do DDL in a transaction and put multiple DDL statements in the same transaction. So you can rename columns, you can add columns, you can create tables and drop tables and create indexes, all within a single transaction. Why should you care? Well, by being able to do that, you can effectively roll out new schemas in an atomic way. So if you write your application to understand either the old schema or the new schema, you're guaranteed an application will not see a partial schema because the DDL is committed atomically, even though there are multiple statements within the DDL statements in that transaction. All the DDL is committed as a whole. I know there are other database systems who cannot do this. This is actually very hard to do. We do it very well. So again, feel free to kind of research that and see if that would help you do some things. Template 1, that's one thing I think a lot of people have never heard of before. So for example, if I go into template 1 and I say create table, new tab, okay, and then I exit out of there, and then I go and I say, let me do this. There we go. So if I say create table, I'm going to create database, new DB, Okay, and I switch over to new DB, and I look at what I have. I have a new table. Well, I just created a new database. Why do I have a table in there? Well, I have a table in there because, as I kind of explained before, um, if you create something inside of template one, it will automatically be created in all databases. So that's really why it's called template one, is a template. So effectively, it will you create anything you create in that template database, whether functions or tables or indexes or extensions, automatically for all new databases they get created. You can even do this. You can actually specify a different template database instead of template one. Where is it? Here you go, template. So you can actually say, I want a copy of another database, just make a new copy. So you just specify the copy of the database, and bingo, you've made a copy of that database. The only restriction, nobody can be in the database when this is happening. So that's the only kind of downside. Okay. Virtual columns. I just wanted to kind of let you know this existed. If you wish to create a column that doesn't already exist, and you just want it to be computed, a computed column, you can effectively create a function. Here I'm creating a function called full name. And by creating a function called full name, I can now select customer.fullname, and it will effectively run the function and make it appear as though it's a column in the table. Kind of cool. Postgres 12 will have something called virtual columns, which is similar, or generated columns, which is similar to this. But again, unless you're not running Postgres 12, this is kind of a nifty feature. Okay. Finally, in terms of SQL, we have time zones. Again, I'm not going to get into this in detail, but effectively, this blog entry from February of this year explains how to take a timestamp without time zone and shift it to any time zone you want it to be in. And it also allows a timestamp to be switched to another time zone. So, for example, if I have a time and I want to say, what time is that in Tokyo, I can effectively just take the current data and switch all the data to appear in Tokyo. Again, it's really good for display purposes where you've got sort of an entry. Let me see if I can find a good example here. So yeah, here's an example of a time in Chicago, and now I want to. Oh, that's not a good example. Here's Here it is. So here's a time in Tokyo, and I want to figure out what time is that in Chicago. So I guess 7 a.m. that date in Tokyo is actually 1700 in Chicago. So databases are really good for time sort of manipulation stuff, and I think if you have not seen that before, I think you should take a look at it. Finally, I just wanted to show you one or two things about PSQL. I could do a whole tips and tricks just on PSQL, but I just want to show you three things. / ? If you've never seen it before, there is a wealth of stuff in here, and please look at it. PSQL is considered to be one of the most advanced client-side SQL tools of any database, and I think it has a well-deserved reputation for that. Not only does it have introspection commands that introspect into the database, like the /D commands, but it has a whole bunch of macro capabilities, variable capabilities, and so forth. And formatting, the ability to format in so many different ways, I think is incredibly powerful. /H, of course, allows you to see the syntax for any command that you're interested in. So if I do /H delete, I actually see my delete command with all of the options. And you might notice, for those of you who have been using this before, I'm using Postgres 12. We have a new feature coming in Postgres 12, which will give you a URL to the documentation for that command. So great idea. I think it came from a different database, but the idea is not only did we give you the syntax, but we give you a URL. And again, if I was on Postgres 11, it would send me to the 11 docs. So again, it has that sort of steering capability, automatically knows what version you're running. and will send me, in this case, to the Postgres 12 docs. Okay. One final thing I wanted to show you in PSQL is the use of variables. Use of variables is enabled with the word set. So if I set var to equal 7, and I say select var plus 1, I get 8. Kind of cool. I can do strings. I can set var2 equal like hello. Okay. And I can say select var2, and it didn't work. Why didn't it work? Well, it didn't work because it thought I typed this. So you're kind of like, well, the 7 worked fine. Why is the hello not working? Well, I don't need single quotes around the 7 because 7 is 7. But for a string, I have to have single quotes around it. How do you fix that? Well, the way you fix it is you put single quotes around the variable name, and it then quotes the variable. You might think, that's not kind of very interesting. Well, I could do set var3, and I could do this. Okay? And then I could say select colon single quote var3. Remember, I have to use the single quotes because it's a string. And now I'm selecting the ls. The ls is now a variable. So I could now say create table ls x text, and I could say insert into ls values, and I could say var3. Select star from ls. And so now what I've actually done is I've taken ls and I've thrown it into a variable, and then I used it to do an insert. Okay. Again, there are thousands of things you can do in PSQL. I'd love to do just the tips and tricks just on PSQL. There's so much there in terms of formatting, output, in terms of sort of introspection and how you can sort of get to know the database really well. I know a lot of people like pgadmin. That's a good tool too. But I think PSQL is just a fantastic tool. So going back to the slides, that does finish the number 15 of what I wanted to show you. So that does complete the 15 tips and tricks that I thought were interesting. Again, we started with hardware. We talked about internals. We talked about monitoring. We talked about SQL. And we talked about PSQL, those sort of 6 things that we kind of went over. So what I'd like to do is to open it for questions. I know there's a lot of stuff I threw at you. Again, we only had 38 minutes here, and I didn't want to bore you. I just wanted to kind of give you a real quick spin through some of the really kind of interesting nooks and crannies that are in Postgres, and sort of give you ability to kind of use it as a better database. There is so much in this product, so much in this piece of software that is available to you, and I just wanted to kind of crack that door open a little bit to give you an idea of what you might be missing and what things might be of interest to you in really taking full advantage of that database. So thank you very much.
All right, thank you, Bruce. That was a great presentation, a lot of awesome information there that you shared with us. So now that we're in the Q&A session, we have a few questions for you before we conclude today's session. So the first one is actually related to what you were just talking about, PSQL. So
yep.
Why is PSQL so powerful compared to other tools?
Yeah, that is a really, really great question. So historically, the way that proprietary vendors develop tooling is that they create a team inside the company to develop the tool. And everyone gets on the team, and they have meetings, and people are assigned to the team, and they go through the development process, and they release the product. Then they get some bug reports, they fix them, and then they kind of stop. Like, there's not a whole lot of need for the company to continue improving something that works, okay? So if you think of, I'm just thinking of my own history, the tooling that we used to have around Informix, the client-side tool. I think it was Access DB or DB Access. That tool didn't change for 5 or 6 years. I think once it finally changed, I think they added like one menu item that wasn't there before. Because there's no real financial, usually for client-side tooling, there's no financial value to a company to continue improving it. Unless you're something like Toad, whose their job is just to do tooling. In that case, they're always improving it. But most vendors, they just have the stock client tool and they just sort of throw it out there and then forget about it. Frankly, it's true. One of the interesting things about Postgres, because it's open source and because it's open to development from users will be playing with the tool and they say, "Oh, I'd like to use variables, but how do I do quoting? Oh, well, what if we use single quotes around the variable name, and therefore that would make the variable be quoted. That's a good syntax, right? Or maybe we should put the URL at the bottom of the help item, or maybe we should have a way of doing backticks or so forth." So what happens is every release of Postgres has a 5 or 10 PSQL improvements just because people think of things. And again, there's no financial motivation for this, but they just want a better tool. And and the whole project is that way. We're always polishing. We're always sort of taking things to that next level because, again, engineering and providing the best possible tool is really what we're all about. There's no real financial reason for it. It's just more like people like tools. People are using the tool. They realize there's a missing something here, and they say, "I can do that. I can write that patch, or at least I can suggest it to somebody, then somebody else will write it for them." So that's why that tool becomes so good.
Absolutely. Now we have another question here, more towards the monitoring section. What is the best Postgres monitoring tool?
Right. Okay. So let me cheat and hop out for a second. No, that's not going to work. Hold on. There. No. Since I have to go to my own website. Okay, we'll do that. Right. We'll do it this way. Okay, so let's want to scroll down. I wanted to show you a specific slide here because monitoring is a really, really complicated topic. And I've been thinking about it for a long time. So here's the slide I wanted to show you. So when you're talking about monitoring, we have to kind of put that in context. And having really thought about monitoring for obviously at the database level for a long time, I came up with this slide, and it's really separated into two parts. One is the left-hand part, which is the reporting part, and the other is the right-hand part, which is more of the alerting and aggregation part. So when you approach monitoring, you have to decide kind of which one am I looking at and which ones am I going to kind of want to deal with. If I look at the reporting part, it goes from the top level, which is the operating system level, okay, to the process level, then to the query level, then, and you saw this already, parser level, planner level, and executor level, right? So if you're looking at reporting, are you reporting at which level? And then on the right, where it really gets interesting, what about alerting and aggregation? You can use command line tools like SAR or check Postgres or log temp files. You can use TaylorMail. And then inside the database, we have pgstat statements, logmin duration statement, pgbadger, auto-explain, pgstat all tables. Again, these are all built in or at least freely available in Postgres, which allow you to kind of see the Postgres system at an alerting level, at an aggregation level, but you see it at different stages. Obviously, if we're at the operating system level, we're at a much higher level than if we're running something like auto-explain or pgbadger. So again, really trying to find the best one, hard to say, but you should think of what level am I really looking at. Now, there are some larger tools which sort of allow you to kind of see things at a higher level and try and take these pieces and put them together. So check Postgres for alerting. I think is super valuable. You may not have heard that before. Nagios, of course, has a very powerful Postgres plugin. For server analysis, I hear a lot about Zabbix and Nagios. Prometheus and Grafana, huge now. Not so huge a couple years ago, but I hear about them all the time. Make amazing, and they're primarily, Prometheus, Grafana are primarily display. They're more graphing or visualization of data kind of platforms. And again, if that's the type of thing you're looking for, they're really good for that. Again, if you're looking at the query level, then we're looking more like something like a PG Badger, which is incredibly powerful. And PG stat statements, auto explain, also really, really popular. And then it's the commercial level, Postgres Enterprise Manager, really unmatched in terms of sort of pulling this all together in a full dashboard that pretty much has things at all of the different levels and has a really powerful alerting capability. Of course, created by Enterprise DB, but is really sort of, I think, the gold standard for this. There are some other ones, Circonus, Vivid Cortex. I happen to know the people who are behind those. Those are more, they do other databases as well as Postgres, I think, as far as I remember. So they're a little wider in terms of their scope, but a little less focused on Postgres in terms of having as wide of a span of capabilities as Postgres Enterprise Manager. Again, this slide is actually on my website. So if you just want to go to my website, there's it's this slide under this right here. I don't actually have a slide for it in the main deck, but that would be that. Another thing I was just kind of curious if you've never seen this before. If you're curious what the community is doing at any given time, PG Life on my part of my Momjian domain is actually a live dashboard of all the email posts, the IRC, the events, the blogs, and so forth. So if you're ever kind of curious what's going on, this is a great place to go.
Awesome, great. So here is another question. For sorts that exceed work mem and write to PGSQL TMP, what are thoughts of having a soft link for PGSQL TMP that points to RAM disk or isolated storage?
Yes. So actually, that is exactly what I did in that one example that I did. Let me go back to because I got stuck here. Yeah, so when in that work mem particular blog entry, that is exactly what I did. Is I created, to do the test on TempFS, I effectively created a temporary file system and then shoved it out there. And you can see what's kind of interesting is that it doesn't make that much difference. I think if you're pushing a lot of data to a magnetic disk, it makes a pretty dramatic difference to use a temp file system. I was kind of shocked that there was so little difference between the temp file system and the SSD. But yes, you certainly could do that because there's no static data here, exactly right here. Right, this text right here. This suggests that creating a symbolic link from PG data to a memory-based file system might be wise. I did that for the test. It took 30 seconds. So in fact, that's exactly what this blog entry suggests.
All right, awesome. Another question for you. In getting started with partitioning, would you recommend using a tool like pgpartman or just use the standard Postgres partitioning functionality?
I have a mixed feeling on that. As you may know, the partitioning has been getting better every year. So when we originally were doing partitioning without the partitioning syntax, which would have been prior to Postgres 10 or 11, pgpartman was almost a requirement because you had to, before we had the create partition syntax, you had to create the child tables, and you had to create the symbolic, the check constraints, and then you had to create the trigger rules and so forth. That was just incredibly a pain to do. And PG Partman was incredibly useful for that. Now that we have we have the create function, the create partition syntax, and we have sort of auto routing, so you don't have to create the triggers anymore. You don't have to create the child tables. The necessity of PG Partman is being diminished over time. As far as I know, the major advantage to PG Partman, and this is still useful, is the ability to auto create partitions if for data that doesn't exist. So in Postgres 11, what we did was we allowed for rows that did not match any partition to go into a default partition. So if you are doing a time series and you forget to create the next month, you can create a default partition and the data will all go into the default partition. It won't fail. It'll just go in the default partition. I think PG Partman has the ability to create a series of partitions and auto create them as necessary. So I think my point is that there was a time when PG Partman was almost a requirement for really enterprise production use for community Postgres. That's less true now as the partitioning gets better. And I think PG Partman will kind of decrease in usefulness. But I think there are still some cases where it has usefulness, particularly, I think, in the auto creation of partitions.
Awesome, thank you. All right, so another question here. How can I learn more about Postgres internals?
Great question. So we do have a wiki page, a developer wiki page, and I'll pull that up for you. It should be the first hit, yeah. I believe there is an internals. Yeah, what information is available to learn about Postgres internals? So this is on the wiki page, and I think it gives a good kind of spread of what's here. Just be prepared. It can take weeks to really get the whole concept of what's going on, and it can take even longer if you want to modify the code. But there are people who can kind of help out. Typically, IRC channel is really useful for that, where you can kind of ask questions when you get stuck, and get people who know the internals to kind of answer it for you. But it is a daunting piece of software. I mean, I remember when I started 23 years ago, and the software was much smaller then, and I was still overwhelmed, and now it's probably twice as big. So it is a tremendously difficult piece of software, partially because of what it does, and partially because of the multi-user nature of the software. Anything that's multi-user becomes complicated because you have locking and so forth. And of course, the performance requirements mean that there's a whole bunch of subsystems and caches and so forth that make it pretty interesting. But if you just look at the code, which we can easily do, it's not that scary. So if I go to PG top, so if I go to source, backend parser, and if I look at parse clause.c, for example, it's not super scary. I mean, it looks pretty good. Like there's a lot of comments, everything's kind of clear to use. You may not know what a range variable is, but that's sort of where you start digging into the code and going through the backend flowchart to sort of understand what the subsystems are and how what different structures are out there. I do have an internals presentation on my website, so if that's of interest to people, I think there is a recording of it as well. But let me just back up here. I'll just open a new tab. So yeah, under my, there is an internals section. This first one is pretty detailed in going through the internals and kind of walking you through the different stages of the server.
Alrighty. So we have time for a couple more questions. Is it safe to use SSD disk for database because of limit of write counts and database optimization rewriting data?
Okay, that is a great question. So, um, there's three things I want to point out of SSDs. First, you have got you databases are only safe to use. I'm sorry, SSDs are only safe to use for databases if they have a battery-backed cache, what we call a BBU. Battery-backed unit is what it technically means. And what that means, and you'll see it if you look at the drive, specifications. It'll talk about some type of supercapacitor or battery, uh, and effectively what that is used for is to allow you to have the cache of the. Um, I'm sorry. It allows you to have the cache of the SSD have a battery on it, because SSDs don't write directly to the chips. You always write to a sort of a cache or a buffer on the SSD, and then the SSD reorganizes that and then writes it to the chips. Okay. So effectively, you're not doing a lot of rewriting as you're suspecting. What you're effectively doing is you're writing to the cache on the drive, and then the drive firmware is reordering it, and then it's writing it to the to the actual chips. So that's kind of what's happening there. I'm actually going to pull up a presentation that I did a while ago, but effectively this is the way the SSDs work. You have a staging area, which has got to have a battery on it. And if it doesn't have a battery on it, then effectively, if the system loses power, you lose the cache right away. And when you lose the cache right away, then you've lost data, or your database becomes corrupted. So in the early years, people were not using SSDs because early SSDs didn't have a battery. So everyone was like, when SSDs came out, it was like, oh, great, let's use SSDs. And the first people who sort of used them for databases, as they had power failures, were losing data or corrupting their database. And that's because they didn't realize that the database never writes directly to the NAND. They don't write directly to the chips. They write to the cache. Then later the cache writes to the chips. So, and you're right. If we didn't do that, then the chips would become worn out very quickly. So that's why the cache, when you have a cache on a disk, that disk cache can be bypassed. You can turn it off. Okay. For an SSD, you can't turn off the cache. You'll burn out the chips if you do. So effectively, you always have to use the cache, and the cache always has to have a battery. In terms of wear indicators and so forth, again, going back to my first tip, I do advise people to use Smart, because Smart will warn you as an administrator if your SSDs are becoming worn, and it will warn you long before you actually have a problem, and you'll be able to swap it out. So again, kind of comes full circle. Smart is actually a really good reason to important thing to use when you're using SSDs, because that write indicator is one of the Smart indicators that's monitored by the Smart daemon.
Great. Thank you so much, Bruce, for taking the time to answer all these questions. Unfortunately, that is all the time that we have today. And I want to thank everyone for joining the webinar. And just as a reminder, we will be sharing the recording along with the slides with you as soon as possible. So you'll be getting those afterwards. So yeah, thank you for joining, and have a wonderful day. Thank you, Bruce.
Bye-bye.
Bye.